Okay, welcome. So test 2 is on Monday, which we kind of talked about, but I confirmed it. I kind of discussed on last Monday, this past Monday days. Oh, that's not where I wanted to go. I wanted to go to Moodle. So what I did was I posted a practice test because the format is going to be a little bit different from test 1, which I warned you about with test 1, that it was all one piece and then the future tests would be broken up into smaller pieces. Okay, and so let's see here. Okay. So test 2 is here. Okay. Let's see if I can get it all in one. All right, that's okay. Okay. So as it says here on your Moodle page, and you'll have time to review it later, I just posted this, or I just made it available earlier this morning. And so you might not have seen it yet, but it's in its own block following this week's or next week's block. And so that you kind of have to scroll down a little bit more. But what I've done is just explained that it's made up of 4 parts. And so each part has a short answer question, which is 1 or 2 marks, depending on, how many questions there are, and 1 long answer question, which is going to be 3 marks. So long answer, a little bit more thinking, right? Maybe a timeline or something like that. So each part has a time limit of 20 minutes, okay? And you must complete the first part in order to move on to the second part, okay? And that's the reason I didn't want to do that for test 1, because there were so many different types of questions that we'd had to do. And so I wanted you to be able to scroll around and pick the one that you felt comfortable with. But for these ones, they're all basically kind of similar, okay? And so you'll have to move through them chronologically, okay? And so just because this is a test bank, so using a test bank, you won't be able to review your test after it's closed. There are a couple of notes about your work, okay? So you have to submit your work as a single PDF again, which you did for test 1, and it has to be before midnight. And I have to add within 10 minutes of submitting your, within 10 minutes of submitting part 4. Yeah.
Professor?
Yes.
Can I ask a question?
Yes.
Sorry, I see on Moodle that it says on Sunday.
Oh, the practice test is on Sunday, is due on Sunday.
It says quiz 4.
Oh, quiz 4. Oh, quiz. Okay. Yeah.
It says on closes on Sunday.
Yeah, quiz 4 is also a timed quiz. So let's see here. I closed it on Sunday, so it closes on Sunday at midnight, because you should do it for practice before the test anyways.
So that's not the test?
No. But it's good practice for the test.
Okay.
Yeah. Let's see here. Yeah, so assignment 7 is on kind of the tail end of chapter 5. Let's go ahead and mute here. There you go. And then quiz 4 is basically on all of chapter 5. Nothing too crazy though, because it has 4 short answer questions in it. And then, oh yeah, That's what I was talking about. So then the practice quiz or the practice test, like I've said, is not for marks. It's just for practice. Okay. And so you don't have to do it, but it might help. Okay. Especially to kind of understand the flow of the test. Okay. Well, did you have another question for me?
So do we have to do the quiz 4?
You do have to do quiz 4.
Okay, it's on Sunday and assignment number 7, right?
Yes. Yeah. Which is
both
all
of them.
to prepare for test 2. Now, I'm happy to give you more time to do those, but because that material is on test 2, I just like I can extend it if you need me to.
No, it's okay. It's fine.
But, yeah. Okay. Lots of practice. All right. So, all right. So you have to submit your work, same thing as last day. Wait, why is it all weird looking? What happened over here? Got shifted. Anyways, maybe it'll shift back. Yeah. Anyways, I'm gonna leave it for now. That's weird. Oh, another question? Okay, nice. Looks like no. Okay, so if you don't submit any work this time, I will grade you 0. I didn't do that on test 1 because I'm nice that way. But if you don't submit any written work, then I will give you a grade of 0 because it's right there. Okay. If the work that you show in your written work doesn't match the answer that you gave me, then I have the right to reduce your mark that you got. Okay. And so, but also in the same spirit, right? If your work shows good logic and reasoning, and maybe there's just a typo or something like that, then of course I will increase your grade. Okay. And so, so I will look through your tests very thoroughly. In terms of your answers, there are a couple of things that I want you to keep in mind, and we're learning them slowly, right? So you want to give all your answers to at least 2 decimal places. Dollar amounts should be exactly 2 decimal places. You don't do commas. Oh yeah, so then you'd want to show me what you changed in your work exactly. Yeah. Yeah. Nice. You don't want to use any commas, even though we do to make it more readable, right? But Moodle doesn't like that. Always give units, and then rates are reported as percentages to at least 2 decimal places. Now it's got this weird, like, kind of fuzzy thing going on, but hopefully it sorts itself out. Okay. Looks weird. All right. I've decided to make the test open all day on Monday, same thing that we did with test 1. I don't know if that's something that you prefer. Usually it is. But if you would prefer to just have me force it during class time, we can do that. But I know that sometimes people are in different time zones and just you've got work or things like that. So that's why I've got it open, open all day. So test number 2 will be open all day on Monday, right? From 0001 to 23:59. Oops, 59. once you start, right, then you'll have to finish all of them. Okay. Once you start part 1, you will need to complete all parts. Okay. And look at this. How weird is this? Oh. Okay, now it's all normal again, sort of. Weird. Okay. Now it's all normal. Now I'm going to leave it. Okay, and so going back to Moodle, okay, so here it looks exactly like this: part 1, part 2, part 3, part 4. Of course, it's hidden right now because it's not test day yet, but same thing. I did the same thing with test 1 or part 1, part 2, part 3, part 4. I just didn't include it all in the screenshot. Okay, and so lots of practice for you guys. I posted, oh, weird. I don't know what's going on with my iPad today, but everything is just I'm trying to ignore it, but it's hard. So I posted a PDF of a practice test. So these are just practice problems that you can work through. I posted the solutions and also the video where I go through and do the solutions. Of course, it's from way back in 2021, so you can ignore all the talk in the beginning where I talk about we didn't have time to finish chapter 5, but we did, right? And so, but don't worry, it's still a good practice test. Okay, so these are all linked together. Let's see here. So these are all the same practice tests. Okay, and then this is going to be, so, oh man. No. Okay. Do these after the first one, right? So after these ones. Yeah, because here, if you want me, so if you want to watch the video for the solutions, right here, you have problems. So what I would recommend you do is you sit down and you try all of those problems, and then you check out the solutions. How did you do? Right. And then if you need some guidance on a question, then you have the video, right? Then you'll be ready to do this practice test, right? And go through each of the parts, right? And you'll see that the questions are very similar, right? And then it'll just be another time on the actual test. Okay, so lots of practice. Okay. If you have any questions about the test, let me know. But otherwise, let's do some review here. So we're going to finish chapter 5 today. There's just 2 rogue concepts in chapter 5, but I want to do a little bit of review, especially using the calculator. Like I mentioned before, we won't rely on the calculator functions so much for chapter 5, but starting in chapter 6, we will. So that's when we really start rolling here. And I can't remember, I feel like there was a question that I hadn't quite finished. Let's just copy that in here. Copy. Continuing from last day. There. Actually, let's bump this up a little bit. Give myself a little bit more space. Wait, there. Okay. And also we did this on our calculator. Okay. So our calculator functions, and let me just stack these so it looks a little bit better. There. And 43.8482712. That looks better. All right. So what we did, right? We were supposed to determine the number of compounding periods. So we were supposed to find N that it takes for an investment of 10,000 to reach 12,000 if money earns a rate of interest of 5% per year, compounded monthly, right? So there's quite a bit of information here, but in terms of the timeline, nothing too crazy, right? We had to find I, we're trying to find N, and we can use the calculator to do that. Of course, we can use the formulas too, right? We could use N is, and here's our formula sheet. Just to remind you and me. Or we could use the formulas N is the natural log of FV over PV over the natural log of 1 plus I, right? And so I in this case is not a nice number. 0.05 divided by 12 doesn't equal anything nice, I don't think. And let me I just realized I'm not on do not disturb. There, it's better. So we have N is the natural log of the future value, which is 12,000, divided by the present value, which is 10,000, divided by the natural log of 1 plus I, which I'm just going to write 0.05 divided by 12. Because I'm going to do it on the calculator anyways. And so let's see here. Try it beside here. So if I do, let's see here. I'm gonna do it all in one go. How about that? How about them apples? So in the function, there's the ln, okay? And I want 12,000 divided by 10,000. Make sure you have enough zeros, or not too many, maybe. Divided by the natural log of 1 plus bracket 0.05 divided by 12. Close that bracket, and we get the same value, right? I'm gonna bring this in. Crop it up. Oh, try to crop it up. All right, so N is equal to 43.84827. 1, 2, 3. Good. So we get the same answer, of course. It doesn't matter how we do it, right? But let's review how we entered it into the financial calculator, right? So first thing you do in order to show your work for the calculator, then you would just list out all these values in this order, please, because otherwise I have to spend a long time looking for stuff. And so if you're using the calculator, please list them in this order. Okay? And it's just the order of working across your calculator anyways. So then we use a little star to denote which value I'm calculating, right? And initially what I like to do is I like to fill that calculator button with a 0. You don't have to, but I just like to enter something for each value. The interest per year is the percentage, right? So 5% would be 5. Other tips and tricks. The present value and the future value have to have opposite signs, right? So one has to be negative, one has to be positive. And what we said, so for now, it doesn't actually matter which way money's moving. Later though, right? There's going to be a difference between making a payment and getting a payment, right? And so, so what happens is we're going to use the convention that if money is leaving your hands, then it's minus, and if it's coming to you, right, then it's positive. So in this case, right, I deposited $10,000 at the bank at 5%, right, and then it sits there for 43.848 compoundings, right? Oh, Emily, that can't be. It has to be 44 compoundings. That's right, right? But we didn't get there yet. And then I take it home and I can hold my $12,000, right? And so, and it also needs to know how many payments per year, which just is going to match the number of compoundings per year because we don't have payments yet. Okay. Chapter 6, we have payments and payments per year. Yeah. Okay, so technically, right, recall, we can't have 0.84 of a compounding or 0.85 of a compounding, right? And so we can't have 0.8482712 of a compounding. Right? You can have 43 compoundings, but you just can't have the decimals, right? And so what we have to do is we always have to round up for n. Now, like I said, the Moodle quizzes are not that clever, and so usually they don't use the rounded value for n, although I'll clarify on the test if I changed it to be the rounded value for n. I'll make a note on the test if that's the case. Okay. So we would need n equal to 44 compoundings. Right. N always rounds up, regardless of the decimal, right? Regardless of the decimal. For example, if n is 13.024, we would need 14, n equals 14 compoundings to reach our goal. Huh? Moodle isn't that clever, right? So it often uses the unrounded value. Moodle isn't that clever. So it often uses the unrounded value for n. No? And like I said, I'll clarify if you should use the unrounded value or the rounded value for n in the question. So it only asked us for the number of compoundings, but I think it's a good exercise to convert that to years. So how long will it take for 10,000 to grow to 12,000? N is the time times the frequency, right? And so I'm going to use the rounded value. We said, okay, well, however we wanted to get there, right? We get 44 compoundings. And I want to solve for t, and the compounding frequency was monthly, right? So it's really saying that we need 44 months. Okay, how long is that in years? Well, f is 12. So t is, what's 44 divided by 12? 3.66 repeating years, right? It's going to be some number of months if you want, but usually just the decimal is fine. So t is roughly 3.667 years. What if we had used the unrounded value versus if n is equal to 43.8, or what was it? 84827. Clear that one. Okay, so use that previous answer divided by 12. I get 3.654 years. So it does make a difference, right? But you need that extra compounding, right? I'm not going to include, well, okay, fine, I will. Whoops, wrong one. T is 3.654 years. So it does give you a different answer, slightly, 3.66 or 7. Okay. Okay. Let's see here. Call that the end of our review. It was just finishing the question we started last day. Let's see what we have in terms of examples here. Okay. Guess we're ready. We'll see more of the calculator later. Calculator later. Okay. Yeah, let's just do 5.6. I was tempted to do another calculator practice one, but like I said, we're not really going to use the calculator in chapter 5. It's more for chapter 6. So let's finish chapter 5. 2 more sections. Like I said, there are these kind of 2 rogue concepts that we need to cover in chapter 5. So changing interest rates. We've seen that before, right? We've seen changing interest rates for simple interest problems, and now we're going to have it for compound interest problems. And let me just bump up the formula sheet so it's at the top so I don't have to scroll around so much. Okay, so for compound interest, right? So here, this is the one that we're looking at now. Okay. If you compare the formulas, oops, jump around, right? We saw the changing interest rate. So you have R1 for some amount of time, T1, R2 for some amount of time, T2. That's for simple interest. We can have the same idea, but for compound interest, right? But it's going to be some periodic interest rate, right? For some number of compoundings, right? And then some new periodic interest rate for some number of compoundings, and so on and so forth, right? And so same idea as before, okay? But let's just clarify that where I1 is the periodic interest rate for the first period of time. And N1, and maybe I should make it more generic. Let's use, well, maybe that's too confusing. Usually we use I to denote any interest rates, but maybe it's better this way. N1 is the number of compoundings for the first interest rate. Right, same formula that we've been working with, right? FV is PV times 1 plus I to the power of N, but now I just happens to change, right? And it only holds for some number of N. And so PV times 1 plus I to the power of N1 times 1 plus I2 to the power of N2, and so on and so forth. Very similar. So we've got an example here. Let's see here. We're going to do example 190. CIBC changes their rate from 4% compounded annually from the start of 2000, just the year 2000, to the start of 2002. For the next 2 years, their rate switched to 4.75% compounded quarterly, right? So the compounding frequency can change as well, right? The following year, the rate was 3.5% compounded semi-annually, again, changing. You invested $1,000 at the start of 2000. How much do you have in your bank account after 5 years? Okay, so what we want to do is we want to make a timeline from 2000 to 2005, right, for 5 years. And what I'm going to do is I'm just going to have breaking points at each year, right? So 2000, 2005, 2001, 2002, 2003. Oh, I need a little bit more. Need one more. Forgot about one. 2001, 2002, 2003, 2004. Good enough. You invested $1,000, and for the first amount of time, okay, for 2 years, I think, right? Oh yeah, to the start of 2002. So between here and here, R1 was 0.04. And the frequency, 1, compounded annually, so 1. Then For the next 2 years, so that's 2002 to 2004. Okay, so let's map that out. The rate R2 was 0.0475 compounded quarterly. Okay, and maybe I'll use these colors to underline where I'm grabbing stuff from. So quarterly, remember the frequency 2 is 4. The following year, the rate was 3.5% compounded semi-annually, right? And so the following year closes this out, and we are at 2004 to 2005. R3 is 0.035, and F3 is semi-annually, which means it's twice per year. Looking at our formula, though, if we scroll back to our formula, just as before, I need I don't need R, I need I, and I need N, right? I don't need T, I need N. Okay, so I guess we can add T. T1 is 2 years, right? 2000 to 2002. Therefore, I1 is going to be R1 over F1, which is 0.04 divided by 1, which is 0.04. N1 is T1 times F1, which is 2 times 1, which is 2. Let's do the same thing for R2, right? Or the green section if you prefer. The amount of time is 2 years, right? 2002 to 2004. And so T2 is 2 years. So therefore I2 is R2 over F2, which is 0.0475 divided by 4. I'm actually going to leave it like that. I don't want to, I don't think it comes out to a clean number. Let's clear this. 0.0475 divided by 4, I guess, but not really. I'm just going to do that on my calculator here later. And N2 is T2 times F2, which is 2 times 4, which is 8. If it's compounding quarterly for 2 years, then you have 8 compoundings. And then T3 is just 1 year, right? 2004 to 2005. Remember, T is always in years, right? So that's not a surprise here. So therefore, I3, I3 is R3 over F3, 0.035 divided by 2. Oops. And N3 is T3 times F3, which is 1 times 2, which is 2. A little cramped there, but that's okay. Now, right, I remember that everything on the left-hand side of a timeline is a present value. So this is a present value is 1,000. And I want to know how much do you have in your bank account after 5 years? I want to find the future value. Right. So using this formula, let's jot it down more specifically here. So the future value is the present value times 1 plus I1 to the power of N1 times 1 plus I2 to the power of, 2 to the power of N2 times 1 plus I3 to the power of N3. I'm finding it very tempting to add these, but they're actually multiplying, right? So just keep yourself in check there. Right, they're multiplying across, which Yeah, I don't know why, but it was very tempting for me to just add them, I guess. 1000 times 1 plus, so we did some work here, 0.04 to the power of 2. So now we can just plug in these values, 1 plus, and I'm going to keep 0.0475 divided by 4 to the power of 8 times 1 plus 0.035 divided by 2 to the power of 2. So this I'm gonna do on my calculator. If I'm careful with my brackets, I can do it all in one go here, right? And so bracket 1 plus 0.04 to the power of 2 times 1 plus, plus 1 plus, and I'm going to use brackets around these just so it doesn't get confused. 0.0475 divided by 4. 0.0475 divided by 4. Bracket. To the power of 8. And step it down. Bracket 1 plus bracket 0.035 divided by 2. Close that bracket to the power of 2. And all right. I did it. Being very careful with those brackets, right? There's no harm in doing them incrementally, right? And then multiplying them all together. But in a way, I guess I'm lazy. Don't want to do that. So then the future value in dollars, right? It's $1,230 at 0.69502. So in pennies, that's 70 pennies. 1,230 and 70 pennies. Okay. That's only if you have a changing interest rate over the period of the loan, right? So kind of a rare situation, but that's how you deal with it, right? And you have the formula, so it's not too bad. Okay. Let's see here. Like I said, 2 rogue concepts. So the first one was the changing interest rates. The next one, the final section of chapter 5, is continuously compounded rates. Okay, and so it's a special case of compound interest where, and it's very, very hard to fathom, right? Where it's not compounding daily or even hourly or by the minute or even by the second. It's continuously compounding. Okay, and so I can't even move my fingers fast enough for that to happen. But so this idea I find is really hard to wrap my head around. But even though it sounds fantastic, right, to have your money continuously compounding, right? Compounding means you scrape off the interest that you've earned, and then now that's part of your principal, right? And now you're earning money on that. And so what I want to show you is that it's not actually that amazing. The difference in the compounding frequency doesn't change that much, right? And so let's just see here. So maybe I'll start it on a new page. 5.7. Continuously compounded investments. Yeah. It's a special case of compound interest, of course, where interest is, where the compounding frequency is continuously. Where the compounding frequency is F equals continuously. We can't use our calculator. We can't use the financial calculator for continuously compounded questions. For continuously compounded questions. Okay, so we can only calculate them by hand, that's fine. And it's the final thing on your formula sheet for compound interest. Way down here, it's tiny. We're used to kind of big formulas, right? But here it is in the very bottom. People love to forget about this one. It's not common, but it's just so little, it's easy to miss. Okay, and so here, this is for continuously compounded interest rates. Okay, notice that, okay, now we have R, because if F is basically infinity, right, then I can't divide by infinity and not get 0, and it just kind of makes a mess. So we don't do that. We just use R and T again, right? And so where of course FB is the future value as before. Don't really need to say these, but for completeness I will. PV is the present value. R, so E is the function EXP, right? So the exponential function, and E is one of those irrational constants. But R is the annual interest rate, or nominal. We could call it the nominal if we want. And T is the time in years, as always. Okay. So kind of fun. Let's do an example. And you'll notice that it's actually the last example for the chapter 5 examples. So it's kind of a short day today, I think. But my idea was to give you time to maybe get cracking on the practice tests, or maybe the quiz, or maybe the assignment, just kind of give you some time to do some work. All right. So last example of chapter 5. 13 years ago, you borrowed $7,500 at a rate of 2.5% compounded continuously. Okay. So, okay, compounded continuously. And it'll say that, right? So that's when you know, okay, that's when I need to use this formula here. Okay. What would be the equivalent annually compounded rate at which you borrowed this money? Okay. And so, right, what happens if F equals 1, right? So the frequency is going from continuously to 1, right? You kind of expect a huge change, but of course, the purpose of this is to show you that it doesn't change that much. Okay, and so let's just draw this out briefly here. So you have 13 years ago, and presumably today, you borrowed $7,500 13 years ago, and you owe some future value today, right? So the time is 13 years. The rate, okay, the compounding or the rate is 2.5%. So R is 0.025 and F is continuously. So what we're asked to do is, well, what annually compounded rate, right? So what would R be if F is 1, right? That'll get you from the same present value. So PV is 7,500, get you from 7,500 to this future value, right? So we're going to force that to be the same. So first thing we need to do is we need to find the future value. So the future value is PV times E to the R times T. So the future value is 7,500 times E times R 0.025 times T, which is 13. I'm going to use, oops, and maybe I'll do them side by side here so I can see it. 7,500, and then E is going to be in the functions. Notice how there's an E to the X button, right? And so you've got this kind of italicized E, so that's how you know it's the exponential function, and it bumps you up to the top right away. And in the top, you want 0.025 times, oops, back up. I want to go back up there. I'll do brackets around here. Notice how it's very important which level of the calculation you're at, because in the brackets, I want times 13. Okay. So this future value is 10,380 and 0.22984. Oh, sorry guys. Got a tickle in my throat. Okay. So we need to round this, and I'll bring that screenshot in when we're done. But so the future value, hey. This iPad's driving me bonkers. Okay. Oh, I'm writing, but it's not showing up. $0.23. Oh man. Maybe it's good that this is our last example. I need to probably restart my iPad. There. So what we need, I love you. What we need is we need to know, okay, so if it's compounded continuously, it sounds amazing, right? But for 13 years, 7,500 sat there and it grew to 10,380 and 23 cents, right? So now what the question is asking, okay, well, what if we change it so that the frequency is now annually, so 1, right? Then what is the rate going to be, right? So now find now find R. It's not lagging, it's my iPad that's totally lagging for real. We now find R when F is 1. So again, we've got this situation. but 7,500 has grown to, and I'm going to force it to be 10,000. $10,380.23. Okay. T is 13 again. I'm going to force the frequency to be 1 and find R is equal to question mark. Okay. Sorry about this crazy lag, you guys. Okay. So we can use the calculator for this if we want to. I'm going to use the formula so that you have it, and then you can check it with the calculator if you want to, right? Because you would be able to find I per Y, which is your R, right? But so here, right, to find R, to solve for R, we first need to solve for I. Ugh, this is insane. Okay. I'll keep trying only because it's our last example, but this is crazy. There. Okay. Maybe what I'm going to do, maybe it's this app. Oh, I don't know what that is. Why does the Zoom meeting look so weird? Anyways, I think it's okay. Try restarting this app. Okay. It was giving me grief all day today. So why not? All right. So we can solve for I. Copy. Okay, so I will solve for I. Finally, it's working. I should have restarted earlier. Sorry about that, guys. I will solve for I using the formula, but you can confirm the results by solving for I per Y on your calculator, on the financial calculator. Okay, so we have our formula for I. So I is, and N in this case is time times the frequency as always, right? And so N is time times the frequency, which is 13 times 1, which is 13. So I'm taking the 13th root of 10,380 and 23 pennies divided by 7,500 and then minus 1. So notice that the minus 1 is after. I want them side by side. Wait. Just, oh no. Like totally struggle city here today. Okay, there. So what I'm going to do is I'm going to take the 13th root, and notice that it has, so this calculator has the 13th root, so, or you can tell it which root. So you use the N root symbol, and then you're able to put the 13 in there. And I want 10,380 and 23 cents divided by 7,500. Notice that it's 1.0253. That's not what our rates look like, right? And so that's why we need to subtract 1. Oh, and I just realized, I did not bring in that calculator, which I said I would. Oh, well. It's gone forever now. No, it's not. So I get this. So I is 0.0253151217. I is R over F, right? And so I is R over F, which means that R is I times F, but R is just 0.0253151217 times 1. But because this is the end of the page here, maybe I'll put this up here just because I want to keep it. So here, this came from over here. Notice that the difference between 2.5% compounded continuously and 2.5315 compounded annually is just so minor, right? So notice R equals 2.5% compounded continuously is equivalent to R equal to 2.53151 compounded annually. And that's the end of chapter 5. Okay. So like I said, ending quite a little bit, well, quite early today. And what I want you to, or I wanted to give you time to work on that assignment, work on that quiz, and work on the practice for the test, or just relax. It makes no difference to me. But if you have any questions, let me know. Otherwise, good luck on Monday, and I'll be available by text or email if you need me. All right. I'm going to stop this recording here.